In this episode, we shift from the idea of visibility to the idea of reducing risk on purpose. Because noticing problems is only half the job and prevention starts with smart hardening. Hardening a Linux system means making deliberate choices that reduce the ways it can be misused, while still keeping it stable and usable for its real purpose. For brand new learners, the tricky part is that security changes can break things, and breaking things can create new risk when people panic and disable protections just to get back online. So the goal here is safe hardening, which means you move in small steps, you understand what you're changing, and you verify the outcome every time. We are going to focus on 3 beginner-friendly pillars: controlling services so the system exposes less, choosing secure defaults so safe behavior is the normal behavior, and building verification habits so you know what actually changed rather than guessing. A helpful mindset is to treat a Linux system like a building with rooms, doors, and staff who come and go. Every running service is like a door or a reception desk that can interact with someone outside the building, and every extra door is another chance for an unwanted visitor to try their luck. When people harden systems, the first major win often comes from reducing what is running and reachable in the first place. If a service is not needed, it should not be available for someone to poke at. That simple idea reduces the number of potential vulnerabilities, reduces the number of configurations you must keep correct, and reduces the amount of monitoring noise you need to interpret later. Safe hardening starts with inventory, not with deleting random things, because you want to know what roles the machine serves and which services truly support those roles. Services on Linux can be confusing at first because you might see many background processes even on a fresh install. Some are essential for basic operation, some are convenience features, and some are optional services that might not be needed for your use case. The hardening habit is to classify services into 3 buckets in your head: core operating needs, required business function, and optional or unknown. Core operating needs include things that keep the system manageable and functioning, like scheduling, logging, time sync, or device management, depending on the environment. Required business function means anything the system exists to provide, like a web service on a web server or a database on a database host. Optional or unknown is the category that deserves attention, because if you do not understand why something is running, you should not assume it is harmless. The safe move is to learn what it is and why it exists before you disable it, because disabling the wrong thing can cause outages that lead to risky workarounds. A common beginner misconception is that hardening equals turning everything off until the system is quiet, but that approach usually fails because the system still has a job to do. Instead, think of hardening as choosing a small number of well-understood services and making them strong, while removing or restricting everything else. Another misconception is that a service is safe because it is installed by default, but defaults are designed for broad usability, not for your specific threat situation. A default installation may include tools for printing, file sharing, remote discovery, or debugging that you never plan to use. Each one can add complexity and expose more behavior to the network or to local users. Secure hardening treats default as a starting point, not as a guarantee. The most secure system is not the one with the most features. It is the one with the fewest features needed to meet its mission, configured intentionally. Secure defaults are about making the safe choice the easiest choice, both for the system and for the humans who interact with it. In practice, that means building rules that reduce risky behaviors like weak authentication, unnecessary privilege use, and overly broad access to files or services. For example, it is safer when users do not routinely operate with full administrative power because mistakes happen and attackers love to inherit those privileges. It is safer when services run with limited permissions and can only access what they need, because a compromise then has less room to spread. It is safer when network access is restricted to the specific ports and peers that are required, because the system is less visible and less reachable to random scanning. Secure defaults do not eliminate risk, but they change the baseline so an attacker has to work harder and an accidental misstep is less likely to turn into a disaster. One way to think about secure defaults is to consider which decisions are happening automatically without anyone thinking about them. When a system boots, it decides what services start. When a user logs in, the system decides what resources they can reach. When a service receives a request, It decides whether to accept it and how much data to expose. Hardening tries to make those automatic decisions conservative. That often means default deny thinking for access, where you start with minimal permissions and open up only what is needed. It also means paying attention to file permissions, because many Linux security outcomes come down to who can read, write, or execute certain files. Beginners sometimes focus only on network attacks, but local misuse, misconfigured permissions, and overly permissive service accounts are extremely common paths to problems. Secure defaults are the quiet guardrails that keep those issues from becoming routine. Safe hardening also depends on verification habits, because security work is full of changes that feel right but do not actually take effect. A service may appear disabled but still be reachable because a different component starts it. A configuration file may be edited but ignored because the program reads a different file or requires a reload. A firewall rule may be added but not applied in the way you expect due to rule order or different rule sets. Beginners often rely on assumptions, like assuming a setting is active because they changed it, or assuming a system is hardened because it passed one quick check. Verification is the discipline of checking what is true right now, not what you intended. This habit prevents false confidence, and false confidence is one of the most dangerous states in security because it makes you stop paying attention. A practical verification mindset is to ask 3 questions after any hardening change. First, did the change apply? Meaning, is the system actually using the new setting? Second, did the change produce the intended effect? Meaning, did the risk go down in the specific way you expected? Third, did the change create an unintended side effect, such as breaking functionality, increasing complexity, or pushing users toward insecure workarounds? Even without getting into tool-specific steps, you can understand how verification might look. If you reduce services, you verify what is running and what is reachable. If you tighten permissions, you verify who can access sensitive files and whether legitimate tasks still work. If you change authentication behavior, you verify login flows for both normal and administrative tasks. This creates a safe loop where each change is small, observable, and either kept or rolled back based on evidence. Another important part of safe hardening is change control, even if you are the only person working on the system. Change control sounds formal, but at a beginner level it can be as simple as documenting what you changed and why, and making one major change at a time. When multiple changes are made at once, troubleshooting becomes a guessing game because you cannot easily tell which change caused a problem. That guessing game often ends with someone undoing security settings just to restore service quickly. A safer approach is to treat hardening as a sequence of controlled experiments, where you start from a known good state, apply a single change, verify, and then move on. This habit also helps you build confidence because you learn which kinds of changes are low risk and which require more careful planning and testing. It is also useful to remember that hardening is not only about turning things off, but also about reducing the damage if something goes wrong. That is where principles like least privilege and separation of duties matter, even for a single machine. If a service runs with broad access and it gets compromised, the attacker gets that broad access too. If the same account can change critical configuration and access sensitive data, then one compromise becomes total compromise. Safe hardening tries to create boundaries so that failures are contained. For beginners, the biggest takeaway is that boundaries are created through permissions, service accounts, and careful configuration of what each component is allowed to do. You do not need to implement an enterprise-grade design to understand the principle. You just need to see that security improves when you limit what any one mistake or compromise can affect. Hardened systems also depend on keeping them predictable over time, because drift is the enemy of security. Drift happens when systems accumulate changes, exceptions, and quick fixes until no one remembers the intended configuration. A system can start hardened and slowly become porous as new services are installed, temporary rules are left in place, or permissions are loosened to solve short-term issues. Verification habits help fight drift by encouraging periodic checks that confirm the system still matches its intended baseline. Another way to fight drift is to standardize on secure defaults and avoid one-off customizations unless they are truly required. Beginners sometimes see customization as mastery, but in security, simplicity and consistency are often safer than cleverness. The less surprising a system is, the easier it is to defend, monitor, and recover. There is also a human side to safe hardening that matters just as much as technical settings. If hardening makes normal work painfully difficult, people will find ways around it, and those workarounds tend to be less secure than the original problem. For example, if authentication is made too complex without good support, users may write down secrets or share accounts. If permissions are tightened without a clear process, people may demand broad access for convenience. Safe hardening includes communication and empathy, even when you are learning alone, because you want security to be sustainable. A hardened system is not a trophy. It is a tool that must keep doing its job reliably. The best security choices are the ones that reduce risk while still fitting how the system and its users actually operate. As you develop your Linux hardening instincts, you will notice that the strongest improvements often come from boring, repeatable habits rather than dramatic changes. Reducing unnecessary services lowers the number of exposures and makes behavior easier to monitor. Choosing secure defaults moves the system toward least privilege, conservative access, and safer normal behavior. Verification habits keep you grounded in reality, catching misconfigurations, preventing false confidence, and reducing drift over time. If you remember only one idea, remember that safe hardening is a loop. Understand what is there, change one thing intentionally, verify what happened, and keep going. That loop turns security from a one-time event into a reliable practice, and it builds the kind of disciplined confidence that strong defenders need.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.